All right, I think we're good to go. Let me just check if we are streaming on YouTube as well. Okay, looks like we are. We're good to go. Let's just quickly start, right? Many of you must have been attending the classes already as well, right? Many of you must be attending the class for the very first time. So I'll just quickly take a minute here to give you the context of the purpose of these classes, right? Before giving that context and before introducing to this very concept to all of you, I'll just quickly take a minute here to introduce myself. My name is Riya Bansal and I'm currently working as a software engineer at Flipkart. Previously, I have worked at many other companies as well, such as InterviewBit and Unacademy, American Express, and Amazon. I do have a lot of teaching experience. I have been teaching students in the past for a very long time and I am very passionate about teaching. I will be taking your class today on hashing as well, right? Just to give you the context of what is the purpose of these classes and how these classes are structured are. So we have been designing a set of micro courses, right? A micro course can contain 3 to 4 class. In this micro course, we pick a certain topic and based on that topic, we try to introduce you to the very concept from the very basics. So usually the first class is based on telling about the very basic concepts regarding that topic, and the second and the third class is based on solving some intermediate to advanced level problems related to that particular topic, right? And we try to make sure that each of you are able to get as much information as possible and you are able to understand that topic in as much great detail as you want. Right, so today is going to be our special class on this micro course. This micro course is based around hashing. We have been studying a lot of concepts around hashing, right? And today the class will be based on problem solving on hashing, right? We'll also complete the implementation for the hashing as well, which we left in the previous class. So we'll complete that hashing implementation part and then we'll move on to the problem solving. Just one thing to expect from all of you throughout the classes, you must be having a thumbs up button in the chat. So please feel free to make use of that button whenever you feel some topics clear or something makes sense. You can always put in a yes in the chat as well. That helps me to clarify that whatever topic I want to convey to all of you, it is being conveyed well across to all of you, right? Does that make sense? Does that make sense to all of you? Just give a thumbs up and I think then we'll be good to go and we'll start with the content that needs to be covered today. All right, perfect. Good. Let me just share my screen with all of you so that you can see whatever I'm typing, and then I think we'll move ahead and discuss with our topic today. Just to give you a bit of an idea of what we have already done, right? We have discussed how a linked list or a generic linked list, we have already discussed how a hash map is going to work like an hash map is going to be an array of linked list. So let's say this is an array, right? What we studies was that we are simply going to build an array of linked list, right? And linked list is made up of nodes, right? And what is this node? This is the pair, that is a key value pair kind of a thing, right? So let's say this is an array given to me, right? And I have to store the hash map information. So at this index of the array 0, 1, 2, at all the indexes I will have a linked list, and this linked list will store the key value pair like it does in a hash map, right? So you can store multiple elements in these linked lists. When we studied about hash maps, we took an information about what could be the different functions which can be present with the hash maps. One of the functions is going to be put, let's say, key and value, So let's say you have to put something into the hash map. So you are going to put the key and you're going to put the value and you're going to put the dot put function. Let's say you have to get something from the hash map. So you will simply put the key here, right? And the moment you put the key, the associated value will come across, right? If you also have to see if something is contained in the hash map, right? So you will just simply put in a key here and it will tell you true or false, whether that particular key is present in the hash map or not, right? Just to give you another context of how the put function works here, right? How the put function of hash map works. Let's say I put Riya and I put, let's say 2, any number you want. Let's say I put Rahul and let's say I put 7. So in the hash map, this is what it looks like. Riya, that means 2 value, and I have Rahul and let's say 3 value. Now let's say if I do at this particular point of time put Riya 6, so what exactly is going to happen here is the function will check if Riya is already present in the hash map or not. Now since Riya is already present in a hash map as a key here, so what it simply does is it simply updates the value present here. So now in front of Riya, the value here will be 6 instead of 2, right? So if a key already exists, it simply updates its value, right? That is what the whole purpose here was. After discussing the whole concept in the last class, we started with the implementation as well, right? We did implement a good part for the implementation also. Let's have a look for that as well, right? So we first looked across the put function here. So you can see that I have made a hash map at this particular point of time. This hash map is going to contain a node. This node is of the type key value, right? The key can be of, this K denotes that the key could be of any type. It could be a string, it could be an integer, it could be any object. Similarly, it works for value as well. Right now I have made an array of linked list. So this is an array. This part denotes that this is an array and this is the type linked list, and that in the linked list I have this node part present, right? Then we started understanding the put function of the hash map. Let's say I want to put something or add something to the hash map. I pass it the key, I pass it the value, right? So first, for that particular key, I need a unique index for which it will be stored, right? If you will take a look here, I have to store that key value pair at a particular index in the array, right? So that is what the purpose of the hash function is, that whenever you pass it a key value, it gives you a unique index for that particular pair, right, where you can store that particular pair, right? So it gives us this particular unique index. Right now at that particular unique index, we must be having a linked list already present. So this is how you are getting that linked list, bucket array, and that index when you put, you simply get the linked list at that position, right? Again, like I said, you first check if that key is already present in the hash map or not, right? So this find in bucket function which we implemented, it basically checks if that value is already present in the hash map or not, right? So if it is not present, if I get an answer as -1, so you simply make a new node, right, and you simply add that node into the linked list, right, and you simply add it in the end, right? Otherwise, if the key is already present, so you simply update the value. So you get it and you simply updating the value of the node, right? This is how the whole put function works, right? Again, like I said, there is a concept called rehashing as well, right? Whenever the load factor becomes greater than 1, right? What exactly was the load factor was that the number of elements in the hash map, I will simply write it down here only. Load factor denotes the ratio of number of elements in the hash map divided by size of hash map, right? So this is the ratio which is called the load factor, and whenever the load factor becomes greater than 1, we have to do the resizing. That means we need to increase the size of the linked list. So that is what we will be doing here and implementing that part today. Is everyone with me till this point? Just give a thumbs up on both the platforms if everything till this point makes sense to all of you, of what we have covered already and what we are going to cover today as well. Does that make sense to everyone? All right, perfect. Great. So let's move on and let's discuss the next part after this as well. So like I said, first you have to calculate the load factor, right? How do you calculate the load factor? Let's say you do double, right? And after that you do, let's say, load factor, and here you simply do this. So currently the hash map is going to have a size, right? That means the number of elements in the hash map divided by the size of the hash map. And how do you get the size of the hash map? The number of indexes in the array. So you simply take the length of the array here, right? And we can simply say that this is called, or this is how you calculate the load factor. And if I can simply say that if the threshold, or I can say the load factor here, comes out to be greater than 1, right? If it comes out to be greater than 1, then you simply have to rehash at this particular point of time. That means rehashing is required. You simply have to increase the size of the linked list. You have to increase the size of the hash map actually here, right? So that is what the purpose of rehashing is. Let's quickly write the rehashing function as well. Right? So rehashing basically means to increase the size of the array. So first what we are simply going to do here is we simply store the previous array first, right? So that we don't lose any information, we are simply first going to store the information of the previous array, right? So what we are simply going to do here is you will do this, right? This is what you're going to do, and after that the next step is going to be create a new array of double size, right? So you simply do this dot bucket array is equal to new linked list, right? New linked list, that is the type of the array, and the length is going to be previous length into this, and you simply put a typecasting here as well. Right? This is what we are going to do. Now we can simply say that the size of the new array is currently 0, right? अब हमने जो नया array बनाया है, currently there is nothing, so I can simply say that this dot size is equal to 0, right? And now what you're going to do is you're going to iterate over the array, and you're going to iterate over the entire length of the new array, right? This is how you do it, and at each point, like we saw previously as well, at each point you make a new linked list, because this is the new structure that we have made here. So everything has to be made from scratch. Now once you have done this, me check what the issue here is. All right, perfect. Now what you are going to do is we will simply put all the previous values in the new array, right? And what we simply do here is we have to iterate over the linked list in the array, in the previous array basically. So I will go to the previous hash map, right? This is how I'm iterating over the previous hash map. I will get the linked list for all the indexes in the previous hash map here. So this is what I am doing, right? Now what we have to do is for every linked list we are iterating over every node, right? Now when you do that, you simply do this for int j is equal to 0, j is less than bucket dot size, and you do j plus plus here, right? Now you have to put all of them in the previous one. So you simply do node is equal to bucket dot get I, right? And what you simply do is you put that new node into the new hash map again, right? So this is the key, this is the value, you simply put it again. So this is going to be the function of how you have to basically rehash or make a new hash map here, right? That is what the whole I would say part is going to be here, right? Let's do a display function here as well, right? Let's do a display function as well, how effectively you are going to display all the values, right? So आपके पास hash map तो है, but how exactly you display the values of the hash map. So for that also we are going to have a very simple and effective function. All right, let's say you actually don't need this. So what we are simply going to do it, we have to print all the elements. So let's say I go to each and every linked list one by one, right? And what I'm simply going to do is I'm going to print right, this is just for printing purpose that I'm doing here. Now you simply do this, right? You iterate over all the nodes and you take the node of each and every linked list like we have already done previously. This is just I'm doing it once again. Right, and what we simply do in the end is we simply print node plus, let's say, the index, and in the end we say that once you have printed all the nodes, you simply put a dot after that. And just to follow up the whole process here, I'm going to put this in the end as well, right? Let's write a client now and see exactly if this works or not. So if to actually use all these functions, I'm going to make a client here. right? So you simply do map dot put, let's say we have to store the cricket match score, so let's say Pakistan stored 150, right? And then we have India, which stored 200. Then let's say we have map dot put, let's say we have Australia, and they put a 100 score, right? So I'm putting all these values, then I'm calling map dot display. Let's see where exactly are we getting. Okay, this must be J, right? Let me see if the ordering of printing is also correct. Let's try to print it all in the same line. So you can see here that I have added 3 values, right, in an array of 5 indexes. So these values are basically depicting that. Let's put here something to denote the indexes also, right? So you can see here that we have 5 indexes, right? We have essentially 5 indexes of the array, right? And for those 5 indexes, that there are 3 values which are essentially put here, right? So this is how the whole idea and the whole concept works, right? And how you're going to simply put the values in the hash map, right? Let's write one more function also, right? Let's write the get function also. Let's see how the get functions of a hash map work, what will be the implementation, and then we will move forward and start solving the questions. All right, okay, perfect. I'll quickly show how the get functions also work. So for the get function, like I said, the purpose is simply here that you pass this function a key. I'll write the purpose on the top here as well, that given a key we need to return its value. All right, so we have been given a key and we need to return its value, right? Again, for that key you first need to know what is the index where that key is present. So we pass on the hash function again here, we pass on the key values, right? And what we simply do here is that we simply get that index, and for that index we will have a array list, right, for that particular index. That is what we have been saying so far. Now what you simply do is you first try to find if the key is present or not. So for that we already have a find in bucket function, and this is how it works, right? If fi is equal to -1, right, if fi is equal to -1, so this part was checking if the key is present in the linked list or not. If it is not present, you simply return a null, otherwise you return bucket dot get fi dot value, right? So for that particular index you simply get the value and return it, right? So if I, let's say, do map dot get, let's say right, if I do this I should ideally get the value. So I'll print the answer whatever I get. Okay, so first I've tried to find that value. Let's take a look how the find in bucket function works. Okay, this is not. Did we pass on the wrong values? Oh, it should be small, right? I and D is small. So for that we get 200, right? So you can simply see here that whatever value I'm trying to get here, I can simply get that value here itself, and it simply returns me the value. Is everyone with me till this point? You can similarly write a lot other functions as well, right? That will be the same purpose and they will eventually have the same functionality that we are trying to look here, right? Once we have an idea now how these things work, right? Now let's quickly take a look at a few questions now, right? To see how these questions work and how you can base a few problems on the hash map, right? So let me just quickly drop my iPad now and I will show you what question we have to discuss. In today's class, we're going to be discussing some beginners to intermediate level questions, right? So the idea or the whole class will be based on that only. All right? Okay. So I'll tell you what the first question is. Think how you will be solving it, right? Okay. So the first question is you have been given a string. Now if the concept of hash map is clear, then this should be a very easy question. You need to find the maximum frequency characters, right? Let me give you a sample input output as well. So let's say I have the input A, B, 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 D, D and D, right? So here the output should be B because it is occurring 4 times. Let me give you another example here. Let's say A, C, B, D, A, D, C, D, D, E. Now for this particular question, the output will be D because I think it is being occurring 4 times again. 1, 2, 3, 4. Right? So this is how you're simply going to get the question. Now think of an approach of how you can actually solve this question. Then we'll discuss the approach as well, right? We'll discuss the exact solution for this problem also. But first I would want you to take a few minutes. Try to write a pseudocode as well if you get the solution, and then we will discuss. Think of an approach that helps you understand this question, and then we'll together discuss the approach for this question as well, right? We'll implement the problem as well, so you will get an idea of how things will work. Any approach that you think will be useful, any approach that will help understand the overall idea for this problem? Alright, I see a few approaches. Alright, let's discuss. I think Sneha C's approach is correct. That should work as well. Okay. Akash, we don't really actually need to make a character stack. We can work around with we can work around without using that as well. Correct. Shaumia's approach is correct at that particular point as well. So what I can say is, right, what I can say here is that there are multiple approaches to solve this problem, right? There are multiple ways, and you can use whichever way you approach or the approach you feel is useful, right? I am going to discuss an approach which makes use of hashing here, right? So what I can simply do is, since I have to tell the maximum frequency character, right, what I can simply do at this particular point of time is I can make a hash map, and in that hash map, for the key and value, for the key part I can simply store the character, and in the value part I can simply store its frequency, right? Okay, I'll just show the pad. I think it was not visible. So this is what we are doing here, right? We have simply created a hash map, right? We have simply created a hash map at this particular point of time, right? In this hash map, in the key part, we are simply storing this character and the frequency part in the value, right? So once we have created a hash map, what we can simply do is we can iterate over the given string, and put the values here, right? So what I'm simply going to do here is if I have let's say the string A, B, D, D. So if I have this hash map, so I come across A, so in the hash map I'm going to put A and 1, correct? Let's say if I come across A again, I'm going to increase it to 2. I come across A again, I put it to 3. I come across A again, I put it to 4, right? Now I come across B, so I will add B and I will put 1. Like I said, the put function simply increments the value and changes it to the right value you want. So whenever I come across a value again, I simply increase its frequency, right? Similarly, when I will fill the whole hash map here, for D, I will get 5, right? Now what I can do is, I can simply in the next part iterate over the hash map and find most frequently occurring character, right? I can simply do that and it will solve all my problems here, right? It will give me a good idea of how things work and how you are simply going to find the maximum frequency character. Many of you did suggested that approach as well, which is pretty fine and should work for all scenarios, and that is how you approach this question, right? So hash maps do come to our rescue here, right? Hash maps do come to our rescue here, right? And they help us solve this problem very, very effectively, right? And you can see here that the space and the time complexity is actually very, very optimized in most of the scenarios, right? Let's quickly have a look here at the implementation also, right? How the implementation work, how we are going to implement this question in a real life kind of a scenario. Then we'll move on to the next part. Let's call it maximum frequency character. Correct. Snehasi is right. You don't have to make the keys for all the alphabets. Whenever you do come across an alphabet, you can simply then create a key for that. So yeah, that's the thing. Let's say the string that we have is right, let's say any random string, and now you have to tell the maximum frequency character in this string. So let's quickly implement this function now. Right, and here we will simply have a hash map of character and integer. We're basically storing the frequency, right? Let's add hash maps here. Now what we will simply do is we will store the frequency of all the characters in the string, right? For int I is equal to 0, I is less than the, I'll just write it once again. Right, what I'm simply going to do here is I'll do this, right? And if I say that if the map already contains it, right, तो आप क्या करो, frequency update कर दो, just frequency update it, so you get the previous frequency, right? You simply get the previous frequency and you put it back with the increased frequency here, right? And if it is not present in the hash map yet, you simply put it for the very first time, right? This is what the purpose is. And now what you should do is you have character, and this is, let's see, this is a new function that I'm actually introducing. What this function does is, right, the main idea this function, or what it simply is going to do is, the key set function, right? The key set function basically gives you all the keys present in the hash map and store it in a set, right? So this is what this function actually does. Now once you have all the keys, right, you can say that, let's say the maximum frequency here is currently the minimum value, right, and the character with the maximum frequency is, let's say, empty, right? So you go over each and every key now in the key set. This is an enhanced for loop. So we are iterating over all the keys in the key set here. This is smallest, right? And then what we simply do is, if the frequency of that particular character or the key is greater than what is the maximum frequency I have as of now, then simply I update that frequency. Right now the next big frequency is this, correct, right? And also the character with the maximum frequency is that key itself, right? And in the end what you can do is, you can simply return the character with the maximum frequency here. So this is max frequency character. Now if you run this, you will see that I get B in the output, because B is present 1, 2 and 3, 4 and 5, 6. So B is present 6 times. So that is what why we get B in the answer. Right? Is this clear to everyone? Take a look here, see if this whole implementation makes sense to you, and give a thumbs up if it does and you do understand what we are doing here. I believe the overall idea should be clear, right? We can build concepts over that, but the overall idea and the overall reason for this particular question and the implementation should make sense. Otherwise you won't be able to understand how exactly did we get all these values, right? Can you also think of the time complexity for this question? What is the time complexity it took? Think about it. I have shown you the entire code here. You just have to look at this code and then calculate the complexity. What is the overall time complexity to calculate the maximum frequency character using this process? Okay, Akash says linear. What about others? Alright, this is going to be linear, right? Because here you will see that in the worst case, I will have to iterate over the entire string length, right? So this is going to be of the complexity, the length of the string, right? And here also, if I assume that each of the character of the string is going to be unique in the worst case, that length time complexity is again going to be str dot length, right? So that is what the overall time complexity here is going to be, right? And overall I can say that the time complexity for the whole question is going to be order of n, where n denotes the length of the string, right? So that is what the whole idea or the overall concept around this question is, right? This is how I've tried to structure the learning for today, right? This is how we will be going on moving forward as well, for solving different types of questions, right? I'm trying to make this as much beneficial as I can for all of you, right? I'll just take a quick minute here to tell you and put some things in perspective that I think will be useful, right? What I feel is, if this is the way that is useful and this is how you think you will be beneficial, right? Let me just tell you that we have announced our very first batch as well, right? And the batch has already started on 14th December, right? But there's another batch that is starting on 22nd as well, right? So if you feel this is the kind of learning that is comfortable for you, this is the kind of learning which is helpful for you, right? The way I have tried to structure the learning, that way we try to cover the basic and then we have tried to cover the whole concept, right? So if you feel this is something that is useful, you'll be able to learn about more these concepts, please feel free to join this batch as well, right? Let me tell you, we have designed the whole curriculum in a very effective manner, right? Although the micro course that you attend are going to be useful as well, right? But being in a whole structured batch, right, gives you a more fundamental way to learn, right? Many students do ask this question again and again, that ma'am, I know what I want to know, but I don't have a structured way to particularly learn that topic. So that is what I will say and suggest to you at this particular point of time, that how you should structure your learning, right? This course is going to be very structured. You have a set of curated problems. The instructors are well renowned, some people who have done excellent in their fields, and they do want to get you and see you excel, right? We do have like best part about, I feel that about this course is that you are going to get a CodeChef certification, which is going to be free of cost, and you are able to get the certification, which helps you to encourage for the fact that you have been working hard all this while, right? The overall idea is help you prepare, right? To help you prepare for FANG companies, if you do want to get good jobs, if you do want to get placed. So that is what the overall idea I would say is here, right? When you are a part of a special class, you do learn a lot. This is a good way to revise your topics. But if you want something to be structured, right, when to know when to skip from one topic to another topic, when to touch one topic and move on to the next part, you need a structured way to learn all those things, right? So that is what we have come up with at this particular point of time, right? Yes, Nehasis, like I said, working on your data structures and algorithm part is very important, right? That is what is actually going to help you land a good job, right? Most of the companies do want to test you on your knowledge of data structures and algorithms, right? So if you do not have good clarity on those concepts, it doesn't really matter what projects you have worked on, right? Because both of them have an equal weightage. So you have to maintain a balance for both of them, right? And to maintain that balance, you need to have a good understanding of the topics that we are covering, right? And to have the good understanding, you need to start from the very basics, right? And then you need to build your concept building on that, right? Here in the special classes, we only touch upon a few topics, right? We don't cover everything in depth as well, but in these batches we are going to do that, right? The like the current class this is going on, this is a live class. The classes that will happen in the batches also is going to be a live class as well, right? You do get live doubt support in the class as well, where you're going to get your doubts resolved at that very particular point of time, right? And after the class also, we have designed a curated set of problems which is going to help you a lot, and which is going to help you actually learn and basically practice those problems which we discussed in the class as well, right? If you want, you can just have a look here of how exactly we have designed the whole structure, right? The first 4 weeks in fact is going to be just based on flowcharts and understanding programming, right? Then we move on to understanding what is any particular language you want to start with. You can start with C++, you can start with Python, you can start with Java, right? Any language that you want to go for. Then we will start with sorting and searching, and then we'll come across basic data structures, right? We'll also learn about a few additional concepts here, right? Then we'll jump on to advanced level topics, I believe, that is number theory, recursion, DP, discrete mathematics. It is again very important. And then we'll move on to graph algorithms, segment trees, and you can see each and every topic is going to take at least 3 to 4 weeks. So you can imagine how much detailed these all topics are going to be and how much in detail we are going to cover all of them, right? So that just gives you an overall idea of how things are going to work, right? You can also take a look at the instructors here who will be teaching as a part of this course, right? We have Tanuj Khattar here, we have Pulkit, we have Triveni, we have Deepak, right? We have many instructors who are really good at teaching, and they have been doing it for a long time. So they know what they are doing, and they know what is the best way to excel in all those things, right? If you want, you can check out the subscription plan, right? I'll just put in the link in the chat itself. So I'll just quickly show you how exactly you can get all what you are looking for. So this is going to be the page where you will find everything that you want. So I'll just share it in the chat itself. You can go ahead and check it out once, right? You can use my referral code as well, that is Riya Bansal, to get further 10% discount on all the courses and any course that you apply for, if you want to go ahead and go for it, right? This is something just I wanted to put forward to all of you, right? Because I know that many of you have been attending the special classes for a very long time, right? And that is very good that you are very attentive for all these topics, but please make sure you do understand the relevance of a structured learning part as well, right? So if we have a structured learning, we do get the concepts in a little bit more detail and an in-depth manner as well, right? If you have any doubts, any clarification that you would like to have, I'll be more than happy to help you out and answer those questions as well, right? All right, perfect. Moving on with this, I'll just share my screen once again and discuss the next question that we want to cover today, right? This is a very interesting question, right? A little tricky for some of you as well, but try to understand the question in as much detail as you want and ask clarifying questions as well, right? And that will basically help you to get a good understanding of the whole question. All right, moving on. Just give me a second. All right, so the next question is going to be that you are given an array of integers, right? And you need to find the longest consecutive sequence in the array. All right, let me give you an example here. So let's say the array contains 2, 12, 9, 16, 10, 5, 3, 2, 25, 11, 1, 8, 6, right? Now let's see what are the consecutive sequences here first, right? We can see that we have 1, 2 and 3, so that is going to be 1, consecutive sequence. They don't have necessarily to be present together, but there should be a consecutive sequence. Then we have 5 and then we have 6, right? Then we have 8, 9, 10, 11, 12. All right. We also have 16 present, we also have 20 present, and we also have 25 present. Now these are all the long consecutive sequences, right? These are all the consecutive sequences, right? Now what you simply have to do is you take a length for all of them. This is the length 3, this is the length 2, 5, 1, 1 and 1, right? Now for all these lengths, what you simply have to do here is you have to tell the maximum length. So here the maximum length is going to be 5. So simply here the answer is going to be 5. That the longest consecutive sequence for this particular I can say array is going to be of length 5. Right? Does the question make sense to all of you? First tell me that part, then only you will be able to think of any solution here. And you effectively have to print this. You have to print that array list, which is at the maximum distance. So in the output, I will print 8, 9, 10, 11 and 12, right? So this is what my output is simply going to be here. I hope the question makes sense to all of you, right? Now if you understand the question well, you have a good understanding of how the question will work out. Think of an approach for this question, right? Feel free to put your approaches in the chat as well. No, Snehasis, you can assume that the repetition is not allowed. Take a few minutes. I'll give you like 3-4 minutes to think, get an idea of how this question will work out. Then we'll discuss the intuition for this. Feel free to put your approaches in the chat as well. I hope the question is clear to everyone. If you have any clarifying questions, you can feel free to ask those. I'm going to wait for another few minutes, see if anyone do sync up on any part, then we'll move ahead and discuss the approach. This is a good question, so it will require some thinking. Yes, Anirudh, you are supposed to solve that question. Yes, Hiten, if you are a beginner and you do want to learn Python, we do have the batch that is starting on 22nd, which you can go ahead and enroll, and you'll be able to learn Python as well in that batch. Okay, Sneha sees, and how will that help? Not sure if sorting is the right approach, and the moment you apply sorting here, you have a complexity of n log n, so make sure you understand that also. Okay, so Pawan and Sneha sees, sorting an array here means that the overall complexity becomes order of n log n, correct? You're saying that the complexity is going to be n log n. Let's try to look for a more optimized approach. What you're saying is correct. What you're saying will work as well. But let's try to look for a more optimized approach here. Something that will help solve the problem in a more effective way. Not sure, Akash, what you're trying to say here. I have a very good approach for this question. Just try to see if you are able to hit that very approach or not. I'll just give like one more last minute, फिर हम discuss करते हैं the solution for this problem. I would want ideally all of you to think, right? All of you to see and strike a solution. But let's see how many of you are able to get the point. Sure, let's discuss, right? I'll tell you a good intuition for this problem, right? Something that will actually help us optimize this problem for the from the approaches that all of you were actually telling as well. All right? Okay. I'll write down the intuition for actually solving this problem. Then all of you can go ahead and see if that makes sense or not. Now, what I will say here is that if a given number n, right, if a given number n, if we do not have n minus 1 present in the array, right, then n can be a start of a sequence. करेक्ट. आई होप एवरीवन गेट दिस पॉइंट दैट अगर मेरे पास एक वैल्यू है लेट्स से x, और अगर एरे के अंदर x -1 एग्जिस्ट नहीं कर रहा है, देन डेफिनेटली दैट मीन्स दैट x इज गोइंग टू बी अ स्टार्ट ऑफ द एरे. करेक्ट. यहाँ पे द रीजन वाई देर इज अ सीक्वेंस स्टार्टिंग फ्रॉम 8 इज बिकॉज आई डू नॉट हैव अ 7 प्रेजेंट. Correct. The reason why 8 is a start of a sequence is because 7 is not a part of this sequence. Correct. So that is what the overall idea here is, that if for a given number, if we do not have n minus 1 present in the array, right, then n can be a start of the sequence at this particular point of time. Right. और अगर ऐसा है that x minus 1 can never be a part of sequence, other information that we get here is if x, or I can say if n now becomes, अगर n minus 1 start of the if n minus 1 present नहीं है तो n start of the sequence है, and that also means that n plus 1 can never be a start of the sequence. Correct. अगर अब ऐसा करने से n became a start of the sequence, then that definitely means that n plus 1 will never be a start of the sequence. अब यहाँ पे 9 was never a part of the start of a sequence because 8 was, right? Here 2 was never a part of the sequence because 1 was a start of the sequence. Correct. That is what the overall idea is here. Now what I will do is, to store that very information, I will make a hash map. Right, I will make a hash map of type integer and boolean. Right, so this integer is going to store the array element, right, and this boolean value is going to store either true or a false. Right, what does this true value signify is, a true signify if the given key element is a start of the sequence. Right, so if I take the example that I already have, so this will have been present. Right, 8 के आगे 2 present होगा because 8 is a start of the sequence. Similarly 6 is never a part of the sequence, so we have 6 and false. Right, so that is what the overall idea is here. Now let's take a small example here and work out on that particular example only. Right, let us take the same example of this array only, that will give us the better understanding. So we have 2, right, we have 2, then we have 12, then we have 9, then we have 6 and 9, then we had 16, then we have 10, we had 5, 3, then we have 2, 20, 25, 25, 20, 25, 11, 1, 8, 6. कुछ भी आप एग्जाम्पल ले सकते हो, doesn't matter. Now the first step is going to be here to iterate over the whole array. Right, now I've made a hash map here as well. Now what I can simply do at this particular point of time is, I know I have a dot contains functions. Right, I have a put function and I have a get function. Right, I'll make use of these functions only. I will iterate over the whole array. Now for 2, I will check if the map already if the map contains 2 minus 1. Correct. Now if the map does not contain one element before 2, that means 2 is a start of the sequence. Right, so I put a 2 and a true. Correct, that means till now 2 is a part of the sequence. Right, and like I said, if a particular element n is a part of the sequence, then n plus 1 can never be a part of the sequence. So I will also see if 3 is present in this map or not. Now since 3 is not present, you simply move forward. Right, now you come to 12. Now 11 is not present in the map, so I will simply put a true here as well. Right, that means 12 is a start of the sequence here. right? And 13 is not present, so we simply move forward. Now for 9, we do not have 8 present, right? I first check for 8. 8 is not present, so simply this is the start of a sequence. Now for 16, 15 is not present, so that means 16 is again a part of the sequence. Now for 10, I see that 9 is present, right? For a particular value 10, if 9 is present, that means 10 can never be a part of the sequence, so I will simply put 10 and false, right? Now for 5, I will check 4 is not present, correct? So what I will simply do is for 5, I will put a true here, right? Now 6 is also not present, so we simply move forward. So for each value, you check one value minus 1, you check value plus 1. Now for 3, I already know that 2 is present, so 3 can never be a part of the sequence, so I will simply put false. And 4 is also not present, so we move forward. Now for 20, 19 is not present, so 20 is the start of the sequence definitely, right? Okay. Now what we simply going to do here is we move to 25, right? Now 24 is not present, so 25 is definitely a start of the sequence as well, right? Now for 11, you will see that 10 is already present, right? Now since 10 is already present, so 11 can never be a start of the sequence, so you put 11 and you put false, right? Now for 1, what we see here is that 2 is already present, right? So 0 is not present but 2 is present, so 1 is definitely a start of the sequence because 0 is not present. But since 1 is a part of the sequence, so 2 cannot be a part of the sequence, so you simply put a false, right? Now you come to 8. Now for 8, what we see here is that 7 is not present, so 8 is definitely a part of the sequence, but for 9 it is no more a part of the sequence, so you put a false because it is not a part of the sequence here, right? Now what will happen is for this particular part we are at 6, right? Now 5 is present, that means 6 can never be a part of the sequence, so I put 6 and false. Now let's see for all those values which have a true. So what we have here is, one mistake that we did here was that when I have a 10, 11 present, right, and if it is not a part and if it is not a start of a sequence here, right, so 12 itself cannot be a start of the sequence as well, right, because we have that continuity present with us. All right, let's quickly see what all are the start of the sequences. I think we missed that part. So we have 16 as a part of the sequence, and we also, this was true, sorry, I missed that part. Since 0 is not present, so 1 is the start of the sequence. We have 5 as well as a part of the start of a sequence. We have let's see, we have 20 as a start of the sequence, we have 25 as a part of the sequence, and we have 8 as a part of the sequence, start of a sequence, and I have 1, right? So what I will simply get is, after taking all the true values, right, after taking all the true values, I will simply get all those variables which are a start of the sequence. So now I get here as 16, right, and I will simply have 5, I will have 20, I will have 20, 1 and 8, right? So these are all the elements which are a start of a sequence here, right? Now what you can simply do at this particular point of time is, right, now when you have 16 present, so you first keep a counter here as well, which is 1, right, because I have one element so far. Now you see if map dot contains 17, right, now I will get a true or a false value based on that, right? Now since I get a false here, now this means that this sequence starting with 16 has a length 1, right? Now you start with 5 and you check in the map if 6 is present or not, right? Now if 6 is present, you will get a 2, so you increase the length to 2 here. Now you will check if 7 is present in the map or Not, right? Now since 7 is not present in the map, so a sequence starting with 5 has only length 2 here, which is the longest length. Now you will take 20, right? You will try to find 21. You will not find 21, so the value of count will remain 1. Now you will start with 25, right? You will try to find 26 in this map. You will not find it, so that means again the value of count remains 1, which is the longest sequence starting at this point, right? Now I will start with 1 here. I will try to find 2 at this point. I will find a 2. I will try to find 3. I will find a 3. So here the length is going to be 3, correct? Now I will start with 8 here, right? I will try to find 9. I will find a 9. I will try to find plus 1 value, 10. I will find it. I will try to find plus 1 value, that is 11. I will find it. Will try to find plus 1 value, which is 12. I will find it. I will try to find 13. I will not find it. So simply the longest sequence here is 8, 9, 10, 11, 12, which has the count 5. Now after comparing all the count values, I will simply see that this is the answer with the length is 5 and it is starting with 8, right? So the element would have been 8 plus 5. So 8 plus 9 plus 10 plus 11 plus 12, right? So this is like 8 plus 4 more elements. Is this approach clear to everyone? How does this overall question work? Does the overall idea make sense? Because that is very important. If you don't understand the intuition that how it worked, how hash maps are actually useful at this point, then you'll not be able to understand the beauty of hash maps. Right, Akash, it's okay if it is a little difficult to come up with, but yes, if you are able to understand how the overall idea worked, yes, you will be in the future look at the questions with this perspective at least. Take a minute here, right? I want a thumbs up from everyone on this if you got the overall concept, right? Take a look here at the approach and then we will solve it together. Right? Chalo, let's move ahead, right? Let's implement this question as well. We'll see what is the best way to implement this, what are the implementation practices, then we'll move forward. Alright, perfect. So this question is actually very popular, right? Very frequently asked as well, so make sure you understand it. Alright, let's take the same array here only. I'm hard coding the array here. Any random elements you can take. This is not the same sequence we took an example. I've just written any. let's call it LCS, longest consecutive sequence. Let's implement this function. This function is going to return us an array list. In C++ we call it a vector, whichever way you want to call it. Right, now we have a hash map of integer and boolean values. We have a map right. Now what will happen is, first we are storing all the start of the sequences. So the idea is very simple. You go over the entire length of the array, right, and first you will check, or we are checking here, if n minus 1 is present in the hash map, right? And if it does, right, then the current element cannot be a start of the hash map, right? So I will first check if n minus 1 is this number. If map dot contains key, that is this number, what I can simply say is I will put ARR of I and I will put a false. That means current number cannot be a start of the hash map, otherwise it will be a true. Right, now we can simply say if the current number is a start of a sequence, then n plus 1 cannot be a start of the sequence, right? And we can simply say that n plus 1 is equal to ARR of I plus 1, right? And if map dot contains key n plus 1 number, so you simply just go ahead and put a false there. Right, this is what you're going to do. So once we have stored all the elements, right, once we have stored all the elements, now what we have to do is we will get all the values in an, let's say I am storing it in an array list here. What am I storing in the array list? I'm storing the map dot key set, right? So all the keys will come here that are present in the array. Now let's say the max length initially is integer dot min value, right, and int max starting number is 0, right? So I simply iterate over all the keys, right? अभी यहाँ पे सारी keys present होंगी, whether it has the value true or it has the value false. So if map dot get key, right, whatever keys has, it is the, if it has the value true, then only you do this process that now this has become a starting of a sequence, right? So I can say that this has become a starting of the sequence, and currently the number of elements in this sequence is 0, and till the time I have map, I will check all the +1 values now. If map now contains key p starting number plus count, right, मतलब अगर ये value present है, then what you simply do is you do count plus plus, right? That means you're looking for a +1 value, and you keep on doing it till the while loop occurs, right? And after this, if the count comes out to be the max length that you have so far, right? So that means you have find a new max length, correct? And you have the new starting for a sequence is also found, right? The maximum length of the sequence is now equal to count, and the starting of that sequence is going to be this number in itself, right? जैसे हमारे example में 8 was the starting of the sequence and the count was 5, right? So this whole process will do that here, right? After this, you will make a resultant array list, right? And here you will go off from the starting number, right? You will go till the maximum length, max length, and what you simply do is you simply add all the numbers which are from the starting number plus you do I, and how many times you do this till the maximum length, and in the end you simply return this length, right? एक बार run करते हैं, let's see if this runs or not. So for this we get the answer 1 2 3 4 5 6, which is I think the longest as well. All the sequence which I would have got was 1 2 3 4 5 and 6, right? Another sequence will have been I think 10 11 12. One more sequence would have been 16, I suppose. Then you could have a 20 also, and you could have a 25 as the start of the sequence, just that, and you could have a 8 as well, right? I think we covered all. Let's check 1 2 3 4 5 6 7 8 9 10 11 12 13, and we have 6 7 8 9 10 11 12 13, right? So these were all the consecutive sequence, and out of the longest one was 1 2 3 4 5 6, right? Is this make sense? Is the overall question and the overall approach make sense to all of you? Rohan, you can assume that the duplicate elements will not be present, right? And even if they are duplicate elements present, देखो यहाँ पे मैंने क्या कहा था, आप मैप पे पुट करते हो तो एलिमेंट्स ओवरराइड हो जाते हैं. तो अगर आपने पहले एक बार 5 और ट्रू पुट किया होगा तो दोबारा 5 और ट्रू ही हो जाएगा, राइट? सो इन एनी केस यू विल नॉट बी एबल, मतलब duplicates element will not make any sense in this question, right? Have a look here, take 2-3 minutes to see what we have done in this approach, and then we will move forward, and I think we have time to take up one more question, so we'll solve that as well. Just give a thumbs up if the overall approach makes sense here, and the overall idea as well of how we are going to look at this question. What I have implemented is what I was actually speaking as well. So the idea should come in itself and should strike you as well. right? All right, perfect. Let's take one more question, right? Let's see if we can discuss that question in detail. Otherwise, I'll just explain that question to all of you, and then you can think of an approach for that question, right? Okay, perfect. The question is actually simple, right? A simpler question than the previous one, if that was a little heavy for you, right? So you are given two arrays, right? And here I'm saying that the duplicates are allowed. All right. Let's say the first array is 557725, and the second array was 6795555. And what you have to do is you have to find the intersection of two arrays, right? So here the answer will be 7555. Please make sure you remember that the duplicates are allowed here. So what will happen is this and this and this and this. So these three elements and this 17, right? Apart from that, none of the elements are actually intersecting, or I can say are actually same. So this is what I can say here the output will be. Now take a look at this question here. See how the overall approach works for you and share it with me. I'll tell you if it is right or wrong. What concept of chaining here, Rakesh? Any approach that you feel should be useful can be used here. Vamsi, I actually don't need two arrays here. This question can actually be solved using one array only. So one hash map, I mean. Like what you're saying is also correct, but maybe try to use less extra space. Correct, Lokesh. I think your approach is alright and will work as well. I'll give a minute more here for everyone to think. Correct, Akshay, that is correct. Okay, Akash, we actually don't need to store the frequency of both the elements, right? We can actually work around with that without that as well. Think of a way if you can. I'll give a minute here or more so to think, then we'll discuss. All right. Actually, there were multiple approaches to solve this question. Right. It all depends on how efficient you want your approach is. But for those of you who are not able to think of any approach or who do want an idea of how things work, the first approach could have been very, very simple. Right. An approach one could be that you simply sort both the arrays. Right, now when you sort both the arrays, right, and when you sort this, you get right. Now you iterate over both the arrays, right? You have this pointer and you have this pointer. Now this and this don't match. Now this value is smaller, so probably a match moving forward. So you can match this 5 and 5 here, right? So when you match this 5 and 5, so what you get here is intersection. Now when you get an intersection, you move forward in both the arrays. Now when you find an intersection again, you put it. Now when you find an intersection here, you put it. Now when you move forward in both, now a 5 and 7 do not match, right? Now for whichever value you have a smaller, you move forward in that. So now currently, let me show you with a different color of pen here. So currently I am here and first I match these, they don't match. So now I match both of them because I am moving in the greater direction, they don't match. Now I try to match this and this. So this is 7 and 7, that is match, right? And now what we are going to do is, for this we move forward in both of them because I match found. Now 7 and 9 don't match, you come forward. So essentially the first time complexity will be called on for sorting the array, right? So this is I can say a n log n kind of an approach, right? Assuming that both the arrays are going to have the same size, we can say that this approach is going to take a complexity of n log n, correct? Now a better approach for this could have been that first you simply store the frequency of first character or first element. Store the frequency of the first array elements. Right, so for this what we are simply going to do is, let's say we store the frequency So I have 1, 3, 2, right? I have stored the frequency here. Now what will happen is you will iterate over the second array now. This was the first step. The second step is to array, and so its next step was to iterate over the second array and check if the values are present in the hash map, and also the frequency should be greater than 0, right? Now you are at the second array, so that is the second array, that is 5, 5, 5, 5, 6, 7 and 9, right? Now when you are at the second array, you simply see 5. Now it has a frequency greater than 3, that means 5 is an intersection, and here you reduce its frequency to 2. Now for another 5, you check that 5 is present with a frequency greater than 0. You decrease its frequency and add a 5 in the intersection. Now for this 5, the frequency greater than 0, and this is an added part, right? This is an added part, and the frequency now becomes 0, and this 5 gets added. Now there is another 5 which is present, and now there is a 5 present, but the frequency is 0. So essentially it does not form an intersection pair. Now you come to 6, 6 is not present in the hash map, so you move forward. Now for 7, 7 is present, you decrease the frequency by 1, and here a 7 gets added, and 9 is not present, so simply these values are going to be a part of my answer, right? I hope the overall idea makes sense and you are able to understand how exactly we are going to store all the elements here. Right? Is the overall idea and the approach make sense? The approach was actually very simple. You just had to see how the complexity works. Right? Okay. If you have any doubts, please feel to clarify. Otherwise, I think we're ahead of time and we'll end the class, and I'll meet you in the next class with a more set of questions, right? I hope everyone had a wonderful session. You were able to learn something new about hash maps, right? I always try to bring in more questions which give you a different perspective regarding hash maps, right? But then again, like I always say, these special classes are just one specific topic that we cover, and that also although we do try to cover every aspect of that topic, but we cannot cover it in detail, right? So that's something that I wanted to put forward. If you're interested in joining the batch, please feel free to do that. Please feel free to take the subscription and join the batches which is going to start very soon, right? And I will see you in those very problems, right? Okay. Thank you everyone for attending, and bye bye. Good night.